Hey guys, welcome back. Now let us see problem number 1 in Norton's theorem. So this is the circuit diagram given. So 15 volts battery and 4 ohms current source and 3 ohms, 2 ohms and 6 ohms and load resistance 10 ohms. So this is a given circuit. For this given circuit, you are supposed to find Norton's equivalent circuit. So as I told the previous class, that statement of the Norton's theorem. So this is a complex network, right? So this can be replaced with single current source and with single resistance in parallel to single current source. So Norton current and Norton resistance both should be in parallel and again connected across the load. This one is the as it is. So this is the equivalent circuit diagram for this one. So now we have to find Norton current and Norton resistance. Okay, let us see step by step. So procedure is very important. Okay, each theorem has its own procedure, right? Let us start step number 1, finding of Rn, Norton resistance. First you have to find Norton resistance. So what are the steps? Remove the load resistance if any voltage source, and we must short circuit, and if any current source, it should be open circuit. So these three steps are very important to find the Norton resistance for a given circuit diagram. So we have a load resistance here, a voltage source and current source. So apply the three steps to this circuit. First one, remove the load resistance. So I have removed here load resistance. And then next, voltage source is there. So voltage source must be short circuited. So this is the voltage source. We have to short circuit. Okay. So this is the voltage source. And next, current source. One current source also there here. Okay. So this current source must be open circuited. Okay. So open circuit nothing but zero. So we have to make voltage source zero and current source zero. That is the intention. So there is no current source. So this is the final circuit diagram after applying these three steps to this circuit. Okay. So here now you have to look from this side, view from this side, load side, and you have to find the equivalent resistance that will become a Norton resistance. So now when you are going from this side, this is a node. So here the current is dividing, right? So these two resistors are connected in parallel. So complete this branch, this path is connected in series till this point. So this is the same line. So therefore 3 plus 3 are connected in series, and this resultant is again in parallel to the 6 ohms. Therefore 3 plus 3 is 6 is equal to 6 ohms, and the 6 ohms are again in parallel. So therefore there is like this. So if you replay this circuit diagram like this, so this is the 6 ohms, okay, and 6 are both are in parallel. So the equivalent resistance must be product of those two resistance divided by sum of those two resistance. Therefore 6 into 6, 6 6 are 36, 6 plus 6 12. So the equivalent resistance 12 ones are 12 3 are. So 3 ohms. So Norton resistance will be 3 ohms here. So now we got Norton's resistance. Next what you have to find? Next will be Norton current. Step number 2. Now let us see what is the step number 2. In step number 2, first one, load resistance must be short circuited and current source nothing but we have to find, this is called ISC, nothing but short circuit current equivalent to Norton. So when you short circuit, when you remove the load, so this will be the circuit diagram. So first step, finding, we have to short circuit the load resistance. We have to remove the load resistance, short circuit. This is the load resistance. So whatever the current is flowing through this load resistance is called short circuit, is called ISC, short circuit current. This will become a Norton current. So how to find this Norton current now? So take the circuit as it is and the only difference we are removing the load resistance and short circuiting. Okay, so this we have to find now. So by applying nodal analysis, so this is a circuit diagram, and this current, some current is coming like this, and this is the node. Let us say this is a V1. Okay, and so some current source 4 amperes is coming like this. So some current, so sum of the incoming current is equal to sum of the outgoing current. So we have to apply Kirchhoff current law at the node V1. So therefore, some of the incoming currents, this current are coming towards the junction. Therefore, what is the current equation? So let us say the potential difference between these 2 points. So this is the 15 minus V. So 15 minus V divided by this resistance. So you will get current flowing through this path. So therefore, 15 minus V1 divided by 3 plus, and this current also coming towards this node. So what is the current here? 4 ohms, right? Plus 4 ohms is equal to outgoing current. Sum of the incoming current plus outgoing. What is outgoing current? Voltage divided by this 3 ohm resistance. What is the voltage here? V. So V1 by 3. So this is the equation. So now if you simplify this equation, 15 minus V1 by 3 plus 4 is equal to V1 by 3. So if you simplify this fraction, 15 minus V1 plus 12 by 3 is equal to V1. If this 3 goes this side and multiply 3 get cancelled. 15 minus V1 plus 12 is equal to V1. So 15 plus 12, 27. Take this minus V1, this will become plus, and 27 is equal to 2V1. So V1 is equal to 27 by 2. 13.5 volts is the V1. So what we found? Voltage across this node. Now we have to find the Norton current, that is short circuit current, this IS. Now we know this voltage. So this voltage divided by, okay, this voltage divided by Norton resistance. So Norton current is equal to this voltage divided by Norton resistance. So 13.5 divided by 3 volts, 3 ohms. So Norton resistance is 3 ohms. So this is the 4.5 amperes. What is the Norton current? 4.5 amperes. So this is called Thevenin or Norton's equivalent circuit diagram. So now we got equivalent Norton current, we got how much? 4.5 amperes, and Norton resistance is equal to 3 ohms. Now we have to find load current, how much load current is flowing through this. So easily we can apply current divider rule. So what's the current divider? The current flowing in the branch is equal to the total current into opposite resistance by total resistance. So to this branch, what is the opposite resistance? Norton resistance. Opposite resistance by total resistance into this current. So then you will get the current flowing through the load. That's called current divide rule. So we can apply. So in step 3, we can call step 3. This one load current can call step 3. So load current is equal to opposite resistance divided by total resistance into total current. So this is IN written here 4.5 and 3 by 3 plus 10. So 4.5 into 3 by 3 plus 10, 13. So this will become 1.038 amperes. This is the load current. So this is the process of finding the Norton equivalent circuit diagram. After finding all the values, Norton current and Norton resistance, you are supposed to substitute in this circuit diagram and show like this. So this is a Norton circuit diagram. This is the equivalent, Norton equivalent circuit diagram. So I hope you understand. Thank you so much.